Okay. So guys, I'm going to have to do a quick little review of something that you've learned in your math classes. It's called exponent rules. People that have gone very far in math, you should have used exponent rules from time to time. I want to do a quick review for you. So maybe down someplace below, you can do this review for me. I'm going to lift this up and show you how to use this exponent rule. For those of you that remember this from Algebra 1, if I were to multiply three numbers together that all have the same base, but they have different exponents. Let's say this is x squared, let's say this is x to the fifth, and let's say this is x to the ninth. If I multiply those numbers together, all the same base, they all have different exponents. Do you recall what you do with those things from exponent rules? You just add the exponents, right? So that would be x, and then I just add those, that'd be 7, 9, that'd be x to the 16th power. Just as a quick review. You should have learned that in Algebra 1. Now, if I were to divide this x to the 16th, if I were to divide that by x to the, let's say, x to the 6th, when I divide by bases that have the same, or divide by exponents that have the same base, what would you do with those numbers? Subtract. All right. So that would be x to the 10th. Now, I'm going to show you how to determine the strength of the electric force in comparison to the gravitational force just using exponents. That means we won't need a calculator because we can add and subtract numbers without a calculator. So what I want to do is I want to show you how to analyze the hydrogen atom. Those that have been through a chemistry class, hydrogen is the simplest atom that exists. It's got a single proton, it's got a single electron. Now because the proton has mass and the electron has mass, they attract each other through gravity. Because the proton has charge and the electron has charge, they attract each other through the gravitational force. So what I want to do is show you how strong that electric force is in comparison. So I'm doing a pound for pound, charge for charge kind of calculation. These things are attracted through gravity. I'm going to draw some arrows there. Those little arrows are showing a force due to gravity. And Newton's third law says they're going to be the same. It's based on how much mass exists, what that universal gravitational constant is, and how far apart they are. These things also attract each other. I'm going to use a different color. They attract each other through the electric force. Because they have opposite charges, they attract through the Coulomb, the force described by Coulomb's law. Now, what I want to do is I just want to show you how to do what's called an order of magnitude calculation. So, order of magnitude is just going to be an approximation by looking at a power of 10. Now, I'm going to take the ratio of F electric to F gravity. So I want to see how big one is in comparison to the other. The electric force is described by this equation. So I'm going to write it in symbol form. Coulomb constant multiplied by the charge of an electron multiplied by the charge of a proton divided by r squared. I don't like picking on you, Adele, but I know you're in chemistry. Do you guys talk about the size of molecules and things like that? Yeah. A little bit. So that r is describing how big that atom is. Pretty small, right? These things are very small. You might even use units like angstroms to describe that. Is that a unit you're familiar with? Okay, don't worry about it. But anyway, it's a pretty small atom. Now, I want to do the same thing and divide that by the gravitational force, which is here. So all I'm doing right now is just writing down what these things represent. The electron has mass, the proton has mass. The electron has charge, the proton has charge. So all I'm doing is just doing a comparison there. Now, something that you should notice is that I don't care how big that atom is, because how big that atom is the same whether or not I'm dealing with an inverse square law for electric force or an inverse square law for gravitational force. Those two R values completely reduce each other. So I don't care about the size of the atom. I'm going to get rid of the R squareds. So the nice thing about doing ratios is that I don't care what the size it is. It's the same kind of law, so the R is reduced. Now I'm going to use powers of 10. Coulomb constant, for those that were gone yesterday, the Coulomb constant is about Well, it's 9 times 10 to the 9th. What power of 10 would you say that is? Like, what's the closest 10 to the what power would you say that is? 9 times 10 to the 9th. Do you guys agree that's closest to 10 to the 10th power? I mean, it's really close to a 10 to the 10th power. Because that 9 is bigger than 5, I'm going to take that exponent and raise it by 1. So I would say that the Coulomb constant is simply let's go back to black. The Coulomb constant is a 10 to the 10th power. So that's the first value. Now the charge of an electron, you don't have to use these numbers with calculators here. That charge of an electron is 10 to the negative 19. That's how much charge a single electron has. As a power of 10, I would just simply write that as 10 to the negative 19 power. Charge of the proton. Well, the proton is the exact same amount of charge. The only difference is that it's a positive value instead of a negative value. Its exponent is still 10 to the negative 19. So far, okay? All I'm doing is just writing the powers of 10 for each of those values. Now, I want to do the same thing for the gravitational force. So now I'm going to do the denominator of this. Okay, G, for those of you that missed this yesterday, we talked about G being the gravitational constant, 6.7 times 10 to the negative 11. That number is bigger than 5. 6.7 is bigger than 5, so I'm going to take that exponent and raise it by 1. That means it's going to go to 10 to the negative 10. That sometimes is confusing. But I'm going to make that power be 10 to the negative 10. Okay, so for G, that would be 10 to the negative 10 power. Mass of the electron. Now again, you guys you're not going to need a calculator for this, but I believe the mass of the electron is about 9 times 10 to the negative 31, correct? Is that what the table says? 9 is bigger than 5, so I'm going to take that negative 31, I'm going to make that be negative 30. So the mass of the electron is 10 to the negative 30. And then I got to take a look at the mass of the proton. Now the proton is much more massive than the electron. It's about 1,000 times as massive. Its exponent is 10 to the negative 27. Okay, now that sometimes can be a little bit confusing for people, how I'm doing that. But now that I have those things written, I'm going to multiply these numbers on top by adding the exponents. So the numerator becomes 10 to the, and I trust you can do that. You might even be able to do that without a calculator. Negative 19 is negative 38. Add 10 to that would be negative 28. So the numerator is negative 28. The denominator, add those together, and I get 10 to the negative 67. Okay. Now, for both of those things there, I had to add the exponents. Now that I have a division here, I'm going to now take those and subtract the negative 67 from the negative 28. So when I go through to do this, now I would get that the amount of how big the electric force is in comparison to the gravitational force. I better stop this video pretty soon because that thing's going to, I don't know if the video is going to show that it's glitching like that. I have no idea. Can someone tell me what that is? Negative 28 minus a negative 67? You guys agree it's going to be positive? 10 to the 39? Okay, so I want to write that down and then pause for a second and consider the size of that value. Now, most of us don't do a lot with scientific notation, but that would be a 1 with 39 zeros after it in terms of the relative strength. That's a big number. What I'm doing is I'm showing you how fundamental forces of nature compare to each other. Gravitational force is incredibly weak in comparison to the electric force. In order for us to feel any sense of gravity, we need to have something huge like the Earth to be able to pull on us with a huge amount of mass. But for electric forces, we don't need a whole lot of charge built up to be able to produce an appreciable amount of force. Again, the math can sometimes be an obstacle for people because they're like, I never liked math and this and that. Then just use an exponent rules so you guys can see how those two numbers compare to each other. 10 to the 39th is a huge number compared to the gravitational force. Okay, so a little bit of math there. Hopefully that helps you understand where you might use exponent rules, because a lot of times people are just solving for x's and stuff, but this allows you to use one of those to compare those two forces of nature. Okay, I'm going to stop that video there, and hopefully